Welcome to this section on neural machine translation with TensorFlow 2. The problem we want to solve here is that of when we receive an input English text like I love deep learning, we want to convert this into French, and this corresponds to j'aime l'apprentissage approfondi. So we shall be building a deep learning model which gets this kind of input and then outputs this. And as we know, these deep learning models feed on very large data sets. One of these can be downloaded on the manythings.org platform, which contains different data sets like this one. So with this, we shall specify that we're downloading the data set which links French words with English words. So after downloading the txt file, we're gonna have something like this. We could scroll to the bottom and see the number of examples we have. So right here we see clearly that we have close to 186,000 different examples of French English translations. Let's go back to the top. We see that right here we have I love deep learning, and then there's a tab here. We now have j'aime l'apprentissage approfondi. Normally this doesn't come with a data set, but we just included this since that was used in the slide. So you could take this off and we have that. To include your own text as we just did, you could say I love. So right here we have I love deep learning, and then you use a tab and write the French translation, j'aime l'apprentissage approfondi. Now the owner of this. Okay, so that's it. So we have words like go. This means va. See, words have different meanings, or the same word has like 3 different meanings in French. So here we have go, va, go, marche, go, bouge. But nonetheless, the model is going to learn when to use each of these depending on the context. As further, we could see that we have other examples, and in this different kind of examples, we could have the same word go used in different contexts, and that will permit the model know when to use any of the translations or not. So what we're trying to build is some sort of mini Google Translate for English to French translation. If you want to translate to other languages, you could go to the manythings.org site, and then you could get those different translations, say from English to Spanish, English to Italian, or some other language. But for this, we shall work with the English to French data set. So the next thing we shall do is we shall make use of TensorFlow to convert this to one-hot representations such that it can be fed into our deep learning model. We shall first start with those imports. So we run this and then straight to data preparation. Here's the path to the French English or French to English dataset text file. Then the next step is we define the number of examples or the number of French to English translations we shall be working with. For this example, we shall use 2,500, although in practice this is very small. And then we shall make use of TensorFlow's data.stf.data's text line data set to convert each line of this file into a TensorFlow data set. So right here we specify the path, and then we take the number of examples. So what we're saying is if you have a certain TF dataset dot take of say 4 would take just 4 examples, and then TF dataset dot take of 2,500 would take 2,500 examples. And this means that right here we shall move up to where we have 2,500 examples here. So let's scroll down again, get to this. So we should be around this because we could see it from here. That's 2,453. Scroll down again. Okay, so we are about this. So this is kind of where we stop. So we go from this URL that's to a view right to the top. once this is done, we could print out this. So let's take this off. We have for I in text dataset dot take. Let's just take one of the examples and print out that. So with that, we obtain this. We'll see clearly that we have the first line, that's I love deep learning. We have the tabulation spacing, and also right here, the tabulation spacing. So we have I love deep learning, j'aime l'apprentissage approfondi, and then by neurallearn.ai. Let's take two examples. We see that we get the next line. So this is go, this is va, and then this to show the translations source. We could take many more examples, 2500, and we have this. So basically that's it. Let's just stay at one example. Looking at this data, it's clear that this is not ready to be passed into our model, as we need to actually separate this input. So this I love deep learning has to get in as one input, this j'aime l'apprentissage approfondi as another, as it could be an input or an output, but nonetheless, let's just suppose this is an input and this too is an output. So they actually have to be separated. And then this data or this information right here isn't useful for training our model. So we have to get rid of this while using only this one and this. So we shall create a selector function which will select this and return it right here, and then select this other one and this other one right up to this, and then return. So let's understand how this works. We have the TF, the string split, which will split this data into different elements and form a list based on the /t separator, or based on the tabulation separator. Now, how does it work? Suppose we have this input. So let's copy this. Let's have this, which is the I we got right here. We could print out now. We have the TF. Let's copy this actually. Let's do this. Let's copy this. We have this. So what we're doing here is we'll be splitting this I into different paths to form a list. So let's run this now, and you see that we actually formed this list. Let's run this again, and we now have this list, as you could see, shape 3, because we have 3 different elements which are being separated by the tabulation separator. We have I love deep learning, we have j'aime l'apprentissage approfondi, and we have by neurallearn.ai. So that's how we form this list. Now we could select some parts of it. So we could select the first by doing this. You see, we could select the second by doing this, and then we could, in fact, actually we're not gonna select the rest because we'll just be getting rid of it. So that's exactly what we'll do here. So that's what this function does. It gets an input. So let's see this input. Let's have this input text. Let's call this input text. So we have our input text, and that's how we select this. Could take this off. So we selected our input text, and now we have that going. Now we could use TensorFlow's or tf.datas map function. So we have this text dataset, which is equals to text dataset dot map selector. So what's gonna happen here is all the different parts of this text dataset are going to be modified using this function. So if we run this, let's come back to this and run it again. We'll see how the initial sentence we had, in fact, let's restart this. Let's run it again, run this, and now let's copy this here so we could be able to compare what happens after. So let's run this now and then run this, so we could compare what we had initially and what we have now. We have this, which now has been turned to this, as you could see, and then this. We see that this other part is left out, and these two have actually been separated, which is what we wanted. Now let's have this too. See, let's do this simply. We have this. Okay, so from here we see that we have the go, for example. In French it signifies va, and then the others or the other information which is not useful for our model is kept out. Let's come back to 1. Take this off. Okay, so that's it. So we've gone through the first step. That was getting this input, that's going line by line using this text line data set, and then separating it like this. That's separating the input sentence and the output sentence. And then in the next step, which is a step we are already very used to, we are going to use the text vectorization provided by TensorFlow to firstly create a vocabulary, and then from this vocabulary pass every word or link each and every word, like for example the word I, to a corresponding number or value in that vocabulary, which can later on be converted to a one-hot representation. Obviously we have the pre-processing step where we clean our data set. We have the lowering step, that's convert our inputs to lowercase. We take away the HTML tags, we take away punctuation, we replace double spaces by a single space, and that's fine. Then we have this text vectorization, which is standardized using the preprocessed sentences function. We have the output sequence length, which for now we fixed to 10. Now note that with this, we could have the input having a number of sequence or a sequence length of, for example, 3, and an output a sequence length of 5. So the sequence length of the input and the output must not always be the same, because different languages have different ways of representing the same idea. Like in this, for example, we have I love deep learning. This is, we could say 3 words. Here we have j'aime l'apprentissage approfondi, but after passing through the pre-processing step, this will become G space M space L space apprentissage approfondi. So this is going to be treated like 5 words actually, instead of 3 words as we may see apparently here, whereas the English sentence is actually 3. So that tells us that the sequence length of the input and that of the output mustn't always be the same. And obviously, since we're dealing with 2 different languages, that's why we're creating this 2 different text vectorization layers. Once we've declared this text vectorization layers, we can now adapt them to our data set. Now note that for this input, we are going to adapt it to this different inputs or to different English sentences, since we want our inputs to be the English sentences, and then for the outputs we're going to adapt them to the French sentences. So right here we have this training data, which is gotten from selecting the inputs, or that's the English sentences, from the English and French sentences. So we use the map function to map the English French to just English, and then we adapt the text vectorization layer to this data, which contains only the English sentences. And then right here we do the same, but for the French sentences, where we have the inputs and then we obtain the French sentences, and we adapt this output layer to the French sentences. So we could run this and run this. After adapting, we could now map those input sentences to your vectorized outputs. So we have this vectorizer function which is passed into the map function. Here we have vectorized input layer, which was this layer, and the vectorized output layer, which vectorizes the output sentences. That's the French sentences. Here we have the French, and this the English. Let's run this, and then from here we could now say for I in dataset dot take, let's just take one value, print out I. We'll notice that here we have the vectorized output instead. We have the I love deep learning, which is converted into this. This is I, this is love, and this is deep learning. All of this is je aime l'apprentissage approfondi. Now let's go ahead and print out the vocabulary, or the input and the output vocabularies. From this we have this, take this, dot get vocabulary, print this out. We say that we have this, our vocabulary, the English vocabulary, while we could also get the output, which is the French vocabulary. There we go. So that's it. Now let's take the second value. So we'll do this. We see that this is je, but this is for the output. So let's come back to the input. This is I. The next is 81. Love. The next is 591, which is deep learning. It shows us clearly that this corresponds to this input, or the input sentences we had previously. Then if we go to the output, we should have output. Run this. This doesn't match with any that we have here. We'll start with the 6. Run this. See, everything works fine. 692 M. Next is 13 L. Next is 1374 apprentissage, and then finally 72 approfondi. So it shows us clearly that this is the vectorized form of the input sentences, which was gotten by making use of this text vectorization layer, which is given to us by TensorFlow. So that's it. We've converted this, and now we are ready to pass it to a model to be trained.